Hi friends, welcome to follow up. Let's have a look at problem 2661. First, completely painted row or column. In this video, we're going to explain how to use the dictionary abstract data type to solve this problem. In this problem, we are given a zero-indexed integer array called array and an m by n integer matrix called matrix. So array and the matrix both contain all the integers in the range starting from 1 and ending at m times n. So we go through each index I in the array starting from index 0 and paint the cell in the matrix containing the integer array I. So we want to find the smallest index I at which either a row or a column will be completely painted in the matrix. So here are two examples. So in the first example, first paint 1, so it's here, and then paint 3, so then paint 4. Once we paint 4, so the first row or the second column is completely painted, so we need to return 2, corresponding index for 4, right? So in the second example, we first paint 2, and then paint 8, and then paint 7, and then paint 4, and then so after we paint 4, right? So 8, 2, 7, and 4. So the column at index 1 is completely painted. So we're going to return the index corresponding to the number 4, that is 3 in this example. So with that said, let's also look at the constraints. First, m and n are the number of rows and number of columns respectively, and the array has a length equal to m by n times n. So the next several is about the range of m, n, and m times n, and also about the element range. So all the integers of array are unique, and all the integers of the matrix are also unique. So this is for consistency for this problem. So with that said, we are ready to do the coding. So in this problem coding, we are going to use dictionary, right? So each time when we scan the elements in the array, so we need to find the corresponding rows and columns to paint, right? For this, we can construct a map or dictionary. So basically, we use the value or the value in the or element in the matrix or same thing in the array as the key and the corresponding position as the value. So this is easy to get. So then we're going to do the check, right? So which row is full and which column is full, right? So notice that when we paint one element, the corresponding row and the corresponding column is painted by one more element, right? One more element. So with that noticed, let's look at the coding part. We are going to explain the logic in between. So first we get the number of rows and that's the matrix, right? And the number of columns at the matrix 0, right? And then we are going to make a table. So this we can use dictionary comprehension. So here ij, right? So we're going to have the k that is also the tuple ij for I in range m, for j in range m. Actually here, when we use this dictionary comprehension, so actually we used this assumption, that is all the integers of matrix are unique. And the same thing for the array, right? And then we're going to initialize another two sets of variables. So first is the counter. So for this, I'm going to check if in the row the number of elements painted is n, right? Check if equals n. So here next field in the row. So currently it's 0, right? Every row I haven't painted yet. So similarly, I'm going to copy this two sets of variable and we are going to change this to be columns. The columns will check if it equals m, right? Because each column has m elements. So max field in the column, so currently also 0. So once we finish this setting, so then we just need to iterate over the array. So basically for I and element. So basically let's just use I. For I in range m times m, because we know the length of array equal to m by n times m. First we get the current position, right? That is the array I, right? So here actually we used that all the integers of array are unique, right? So we get the position and using this. And then what we're going to do, because rows, so current row, that is R. So there's one more element painted, right? Then we check the max field in the row. So this will be the max max field. Let me copy this in the row, and the current number of elements painted, that is rows R, right? So similarly, the columns at in this index is painted. This column is painted one more element, so we're going to increment counting by 1, and then we're going to update this again. So max field in a column. This will be this one, and the larger columns C, right? Then what we're going to do, we're going to check if max field row. So each row we have n elements, right? If it fully filled, so we're going to have this against n, or so maximum column filled. So this will be checked against m. Then we just need to return the current index I. So as we scan the elements in the array, so we must be able to return an index, so we can stop here. So this forms a complete format of coding. So before we make any comments, let's first do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, that's basically about it for this problem. Let me give a quick summary. In this example, we used dictionary to help solve this problem. So there are 3 places that we used the dictionary. So here is one. So this is for the ease of check of which element or which position is painted. So this is the one. Here we have another 2, that is rows and columns. So basically this will record for each row how many elements is painted. So we're going to check against m. So this columns is basically check for each column how many elements are painted. So this will be check against m, right? So we use this max field in a row and max field in a column to detect if a column or row is fully painted. Once we find such a row or column, we just return the corresponding index for elements in array when we do the traversal. So with that said, that's about it for this video.